Yep, I am live. And today I am live, right? Yep, I am live. Today we will complete the book. We have only one chapter remaining. Shit, no, we have two chapters remaining. The Unix system interface and also input and output. Let's see what is there in input and output. And we also have the advent of code problem that we were doing yesterday. Chapter 7, input and output. Input and output are not part of the C language itself, so we have not emphasized them in our presentation thus far. Nonetheless, they are not part of C language itself, so we have not emphasized them in our presentation thus far. Nonetheless, program interaction with their environment in much more complicated ways than those we have shown before. In this chapter, we will describe the standard library, a set of functions that provide input and output, string uh, handling, storage management, mathematical routines, and a variety of other services for C programs. We will concentrate on input and output. The ANSI standard defines these library functions precisely so that they can exist in compatible form on any system where C exists. Programs that confine their system interactions to facilitate provided by the standard library and can be removed from one system to another without change. Okay. The properties of library functions are specified in more than a dozen headers. We have already seen several of these, including stioh, string, C-type. We will not present the entire library here since we are more interested in writing C programs than that use it. The library is described in detail in Appendix B. Okay, it is in Appendix B. The standard input and output. As we said in Chapter 1, the library implements a simple model of text input and output. A text stream exists. A text stream consists of a sequence of lines. Each line ends with a new line character. Yep. And if the system doesn't operate that way, the library does whatever necessary to make it appear as if it does. For instance, the library might convert carriage, return, and line feed to new line on input and back again on output. The simplest input mechanism is to read one character at a time from the standard input, normally the keyboard using getchar, like this getchar. Getchar returns the next input character each time it is called, or end of file when it encounters end of file. The symbolic constant end of file is defined in standard IO. The value is typically -1. Bus tests should be written in terms of end of file so as to be independent of the specific value. In many environments, a file may be substituted for the keyword by using less than convention for input redirection. If a program prog uses getchar, then the command line this causes prog to read characters from infile instead. Oh, okay. In many environments, a file may be substituted for keyboard by using this. For input redirection, if a program uses prog, okay, causes prog to read characters from infile instead. Okay, so what I understand is this. If I go to and write an input redirect, what is this thing called? Keep using the less than convention for input redirection. Okay, input redirection dot c. So here include stdio.h and main, and yeah, if I have getchar inside this int c and while C equals get char is not equal to end of file. I would like to do put char C. This should be similar to this is similar to cat and the concatenate function. Now I will do clang input redirection and send the output to cat me. So if I do cat me dot slash just cat me and give it input of input redirect, that would be crazy. Will it print? Command not found. Okay. Cat me input redirect. Yes, it does work. So yeah, it is like cat. One more thing. When running an executable outputted by the compiler, I have to do dot slash file name. How can I do just file name? Okay, so I will have to put that function in my system's path. Path is the place where my system looks for programs. You can Today my brain is not working a lot. I ate a lot of food. Yes. Then you can simply run this. So I have to move file to my user local in the bin. Okay. Slash user slash local slash bin ls. Okay. Only the shit npx pip3. These are the only commands here. Shit. I thought there might be more. How to do back in cd. How to go back in cd. Simply do. Oh yeah, cd back, cd back, cd back, cd back. No, like shit. Takes you back to the previous working directory you were in. cd tilde cd minus minus. Okay, okay, that is stupid. And I want to move the cat me function. So mv cat me to user slash loop slash user slash local slash bin. Permission denied. Sudo move cat me slash user slash local slash bin. Password is that okay? If I do cat me with this and given input redirect, yeah, no shit, not date, many, no, yo, okay. So I can make custom commands in Linux. That is crazy. I can write pro. Isn't that the way? That is what I would do when I will write my own web server. That is what I will do when I run my own front end for the web server, which will be based on terminal. And I will be able to chat with people. Okay, okay. Oh, yes, and this is pipelining. If I do this operator, What this does is the output of this function goes as the input for this. But how will I get it? Causes prog to read the characters from infile instead. The switching of the input is done in such a way that the prog itself is oblivious to the change. In particular, the string infile is not included in the command line arguments in argv. Input switching is also invisible if the input comes from another program via a pipe mechanism. On some systems, the command line this runs the two programs, other prog and pipelines the standard output of other prog into the standard input. The standard output of other prog goes into the standard input of prog. So output and output the direct.c include stdio.h main int main, and what would I like to return? I would like to return, let's just return something. This is a string by the output function. Can I do that? Nope. A equals char pointer, a equals yes. Okay. Oh, return type of main is not int. I want it to be this. Output first lang output function output. It cannot be char. Shit. Return type of main is not integer. Then how will print will send it to standard output? So will it be if I do print f a, that does not work. But okay, so what I'm trying to do here is that I'm trying to return a string from this one function, and using pipeline I want to send that string to another function which takes an input from the standard input and prints it to the screen. But the main function cannot return something other than a number, integer. So what I think is that when printf function prints something, it is sending that to the standard output. So I am supposing that when this function output redirect function sends the string to the standard output, it will be pipelined into the other function which is there to catch that string from standard input output through pipelining. And let's see if that works. Catching. It does work. I actually did not thought that it might work. Well, requires a new line. And now output redirect cat me, and yes, it 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 works. This is a string by the output function. Yeah, input char. Yes, I can do this. Yeah, this will store. What will this do? File name Okay, I understand pipelining, not like how it works, but what it does. Int input int. The function this is used to output put char puts the character C on the standard output, which is by default the screen. Put char C returns the character written or end of file in an error is an error occurs. Again, output can usually be directed to a file by file name. Uses put char will write the standard output to output file instead. If pipelines are supported, this puts the standard output or program into the standard input of another program. Okay. This will save into the file, and the standard output by this program will be saved into this file, and the standard output for this program will be used as the standard input for this program. This is called goddamn pipelining. Okay, and something else, write a program that converts uppercase to lowercase to depend on the same name. It is invoked with the RV formatted output printf. Shit, this is the time that they are telling us about printf. Yeah, what are other characters, argument types? Printf, conversions. These are called conversions. Okay, I can use D or I for decimal numbers, O for octal numbers, X for hex, X for hex, okay, and U for unsigned, C for a character, S for a string, F for a float, I don't know, if I have ever used G, I don't know, P for a pointer, percent, no argument is given, print, uh, percent sign, okay, argument length, lists, char pointer, and I really want to move on to, I can read this on my own whenever I want. If I want to read this error handling, standard error, yeah, there is a thing called standard error where the standard error goes line input and output, miscellaneous functions, the Unix system interface file descriptors. Okay, fuck it. Advent of code for 2015. Yes, where were we? We were at question number 3. AOC, advent of code, C, git checkout 2020, 2015, ls, gs, git status, and git unstash. Okay, how to unstash in git. Undo a stash. Git stash pop. Git stash pop. Oh, yep. And cd day c part 2.c. Yes, we were facing problems in this. I don't like that green line there. It add everything and part 2. Shit, the green line is still there. Okay, so yesterday we were facing problems here. Lang part 2. Lang part 2 dot c. Send the output to dot slash out. 2837 as I remember was the wrong answer for part 2, and we were getting wrong answers for other things too. Part 2.c. This is our thing, and when I had provided other inputs such as up, up, down, this should give no up, down. this should give answer 3. Dot slash out. Okay, I got 3, which is wrong. Absolutely wrong. And let me print both of these. Dot slash out. With that. Okay, it is also doing it for the main function, so shit. I do not want to stop it, but I also wanted to stop it. Sunken cost fallacy, game theory, shit. Let's see, it will stop shortly. It doesn't seem to. Fucking hell. 27. I can delete this. Clang dot slash out. Okay. For index 0, I went up 1 step. Okay. And for 2, I went down. So why is it only 1? No, answer is 3. What the heck? Okay. Are there some global things that change after I call the function the first time? Return unique visits. And when is the time when unique visits increases? When I visit a house which I have which none of them has visited. So I do not have to create separate lists for their houses. Of course, yes, yes, yes. That makes much more sense. Memo is nope. I only need a single memory. Yeah, I only need a single memory. Remove current S gives, yeah, I would need current S and current R, but I can replace memory by this. How do I replace? I replace it by percentage S memo S, replace it by memo globally everywhere, and also percentage S, replace memo R by memo globally, and percent down shit, percent S memo R, replace it by memo globally, and percent S index S, replace it by index on the whole line, and percent S index R, replace it by index for the whole line. And yeah, the error has gone. Error's gone. Error's gone. And let's get out. For part 2, and let me do this for this, and for unique visits equals to give unique visits for buffer, and then print it, and I will comment this. Let's see. 2639. Well, the 2 is wrong. The other thing is true. So well, that is up with that. If if unique visits less than 5, then print all of this. And yeah, let's see how that works. Okay, so here for index 0, I did not go up. Well, yeah, now since there is only one list, so I do not have to print 2 different lists. Yep, and I can simply do this. So yeah, for the first time I did not go up, but for the second time I went down. Why did that happen? We'll have to see why did that happen. Um, should I try to print the characters also? Yeah. Print this and the number, and also print the character, which is si line dot slash out. Okay, when it was up, I did not go up. Why did I not go up? Why did I not go up? Why am I checking them? I am checking it to update the current location for Santa and for the robot. Right, right, yep. I have to update it for the Santa and the robot. Okay, let me also print the direction for every time. Print, not print memo. F, printf, this %d, comma %d. This will give me the direction, the new line. And what is the direction? Direction dot x, comma direction dot y, and semicolon, of course, and then dot slash new line. Let's see. When it was up, I got the direction up, and when it was down, I got the direction down. But why then did it not go up? Why then did it not go up? Current, not x, but current s, current y. Santa gives me, this gives me the current location, and after I have updated the location, yep, here I will get the updated location line dot slash out, and I do not. Oh, uh, okay. Okay, that all is for the other thing. That all. Wait, why am I only seeing current location and updated location there? Why is there nothing for the robot? Okay, that makes sense. That makes sense because I am printing for robot when unique visits is less than 5, but I'm printing current location and updated location in every case. But why is this not increasing? This and part 2. Let's see. If has not visited, then go there. But why is has printf hi backslash n. Comment this out. Not slash out, and I did not see any hi there. So what that means is has visited returned wrong, false. But why did it return false? Like, wait, why did it return? Yeah, false. Why did it return false? Is the memo not automatic? That is, for every function that I define memo, do I not get a different memo? That might be it. And if that is correct, then I should at least get the correct answer for this, which is 2639. Is 2639 correct? Okay, I guess we move on. But before that, I want to ask something. ChatGPT. Inside a function, I am defining an array of structures. I'm defining an array of structures. Whenever calling the function, will I get a new array? Wait, let me tell it that it is in C. I am writing code in C. Oh, got it. Yes, C. In C, if you define an array of structure, a new array will be created on the stack each time the function is called. That is what in the stack. That is what should happen actually. Point this and equals to this created array and this. Okay, and print the array contents, and yep, this will create a new array. Now, question number 4. And part2.c, and let me remove this and also remove the print statements from here. Dot slash out. Yo, why am I still seeing some print statements? Printf and here and here and here. Oh, okay. I can do that, and cd and get status, get add comment completed day 3, git push, and now day number 4. This is my puzzle input. This is it. Okay, Santa needs help minifying some advent coins, very similar to bitcoins, to use as gifts for all economically forward thinking little girls and boys. To do this, he needs to find MD5 hash, which is in hexadecimal, start with at least 5 zeros. The input to MD5 hash is some secret key, your puzzle input given below, followed by a number in decimal. To mine Advent coins, you must find Santa the lowest positive number, no leading zeros, 1, 2, 3, 4, that produces such a hash. For example, if your secret key is this, the answer is this, because the MD5 hash of this and this starts with this, and it is the lowest such number to do so. Okay, so this is this is the secret key, and I have to find a number to put after this, the lowest number to put after this, which after going through the MD5 hash gives me, what does it give me? The secret key is this, cause it gives me a hash which starts with 5 leading zeros. Okay, and it is the lowest such number to do so. If your secret key is this, the lowest number it combines with to make an MD5 hash starting with 5 zeros is this, and it is the MD5 hash of this, looks like this. Okay, make there day 4 cd day 4 and part1 dot c include stdio dot h and main, and let me do int c, not int but char secret equals this thing, equals this. Okay, so I have to write a function which finds the MD5 hash. What is MD5 hash? The MD5 message digital digest algorithm is a widely used hash function producing a 128-bit hash value. MD5 hash was designed by Ronald Rivest in 1991, replacing an earlier hash function MD4, and was specified in 1992. And request for comment 1321. MD5 can be used historical and done security. What is the old line of security calculation? Vulnerability application. Yep, algorithm. MD5 possesses a variable length message processes a variable length message into a fixed length output of 128-bit. The input message is broken up into chunks of 512-bit blocks. Okay, 16 32-bit words. 16 32-bit words. Okay. The message is padded so that its length is divisible by 512. The padding works as follows. First, a single bit 1 is appended to the end of the message. This is followed by as many zeros as required to bring the length of the message to up to 64 bits fewer than a multiple of 512. The remaining bits are filled up with 64-bit representing the length of the original message modulo 264. The remaining bits are filled up with 64 bits representing the length of the original number. 64 bits representing the length of the original number. Okay. The main MD5 algorithm operates. Okay. The main MD5 algorithm operates on a 128-bit state divided into 4 32-bit words. The main MD5 algorithm operates on a 128-bit state divided into 4 32-bit words denoted ABCD. These are initialized to certain fixed constants. These are initialized to certain fixed constants. The main algorithm that uses such 512-bit message block in turn to modify the state. The processing of a message block consists of four similar stages termed rounds. Each round is composed of 16. Wait, pseudocode. The MD5 hash is calculated according to this algorithm. Little endian. All values are in little endian. That is, the LSBs are stored in the smallest memory address. All variables are unsigned 32-bit and wrap modulo I do not understand, but this okay I do. Integer, a string of 64-bit and a string called k for 64. S specifies the per round shift amount, and from S 0 to 15. Wait, this syntax number dot dot 15. What syntax is this? This seems to be, is this JavaScript? Seems like it. I mean, they are using var, so yeah. S specifies the per round. I guess Wikipedia is not a good place to read. MD5 algo hash, not hash generator, MD5 generator. What is the MD5 algorithm? Geeks for geeks. Let's see. MD5 is a cryptographic hash function algorithm that takes the message as input of any length and changes it into a fixed length message of 16 bytes. Okay, MD5 algorithm stands MD5 algorithm stands for message digest algorithm. MD5 was developed in 1991 by Ronald Rivest as an improvement of MD4 with advanced security purposes. The output of MD5 and digest size is always 128-bit, okay, that is 16 bytes. MD5 is still the most commonly used message digest for non-cryptographic functions, such as used as a checksum to verify the data integrity, compressing large files into smaller ones securely, etc. Original message, padding and then length, padding appended, and this k is the original number of bits, and then I get L is the amount of 16 bytes and N is the amount of 4 bytes that combine to form the new message, and the new message consists of the original message plus some padding and then the length of the original message. Append add padding bits can range from 1 to 512 bits. The first in the padding bit is 1 and then the zeros, and append length 64 bits k mod. What happens? I have multiple y0, y1, 5 and 512 bits values, and that goes through a hash. Okay, working of MD5. Append bit padding bits. In the first step, we add padding bits in the original message in such a way that the total length of the message is 64 bits less than the exact multiple of 512. The exact multiple of 512. Okay, this is working with bits instead of bytes and working with Bits is a little more complicated than working with bytes. Suppose we are given a message of 1,000 bits. 1,000 bits. So what is a multiple of 512? 1,024. Now we have to add padding bits to the original message. Here we will add 472 padding bits to the original message. After adding the padding bits, the size of the original message output first step will be 1472. Yep, and 64 bit less than the exact multiple 3. Yep, and now the length becomes original message plus padding bits, which is equal to 1472. And then adding length bits. I then have to add length bits. Yep, I then have to add length bits, append length bits. In this step, we add the length bit in the output of the first step. In this step, we add the length bit in the output of the first step in such a way that the total number of bits is the perfect multiple of 512. So therefore, we will add 64. Nope. Using those remaining 64 bits, those 64 bits will represent the length of the output. The total number of bits is simply here we will add 64 bits as a length bit in the output of the first step. Original message plus padding bit. Okay. Output of the first into n minus 64 length bits equal to 64. After adding both, we will get 512 into n, that is an exact multiple of 512. Okay, then initialize empty buffer. Here we use the 64 4 buffers, that is A, B, C, D. The size of each buffer is 32 bit. Okay, size of each buffer is 32 bit. Process each 512 bit block. This is the most important step of MD5 algorithm. Here is a total of 64 operations. Here a total of 64 operations are performed in 4 rounds. A total of 64 operations are performed in 4 rounds. In the first round, 16 operations will be performed. Second round, 16 will be performed. Third, 16 and will be performed, and fourth, 16 will be performed. We apply a different function on each round. That is, for the first round, we apply f function. For the second round, we apply g function. For the third round, we apply h function, and for the fourth round, we apply for the fourth round the I function. We perform OR, AND, XOR, and NOT. Basically, these are logic gates for calculating functions. We use 3 buffers for each function. Wait. MD5. There is an RFC, right? For it. RFC, was it written here? No, it was on Wikipedia. The RFC number for this algorithm. RFC 1321. RFC 1321. Yup, MD5 algorithm. Okay, I think I got this. Reading an RFC, writing my own algorithm based on an RFC. That is crazy. Ronald Rivest. Only 380 citations? Isn't that less? RFC 1321 by R. Rivest, MIT Laboratory. The MD5 message digest algorithm. Status of this memo. This memo provides information for the internet community. It does not specify an internet standard. Distribution of this memo is unlimited. So I can read this without getting sued. Acknowledgements. Thank you. Table of contents. Executive summary, terminology and notation. MD5 algorithm description starts at page number 3, and then we have summary differences between MD4 and 5 references. Okay, I should be able to understand this much. I can use ChatGPT with this. This document describes the MD5 message digest algorithm. The algorithm as takes as input a message of arbitrary length and produces an output of 128 bit. That much I understand. Fingerprint or message digest of the input. It is conjectured that it is con- computationally infeasible to produce two messages having the same message digest, or to produce any message having a precise specified target message digest. Okay, the MD5 algorithm is intended for digital signature applications where a large file must be compressed in a secure manner before being encrypted, encrypted with a private secret under a public key cryptographic system as RSA. Okay, and SHA-64 is used for the same. 256 is used for the same thing, but that gives an 120 256 bit output, and this gives a 128 bit output. Okay, MD5 message digest 5 algorithm. The MD5 algorithm is designed to be quite fast on 32-bit machines. 64. In addition, the MD5 algorithm does not require any large substitution tables. The algorithm can be coded quite compactly. Okay, let's try it. The MD5 algorithm is an extension of the MD4 message digest algorithm. 1 2. MD5 is slightly slower than MD4 but is more conservative in design. MD5 was designed because it was felt that MD4 was perhaps being adopted for use more quickly than justified by the existing critical review. Because MD4 was designed to be exceptionally fast, it is at the edge in the terms of risking successful cryptographic attacks because the output for that can be calculated very fast. MD5 backs off a bit, giving up a little speed for a much greater likelihood of ultimate security. It incorporates some suggestions made by various reviewers and contains additional optimizations. The MD5 algorithm is being placed in the public domain for review and possible adoption as a standard. For OSI-based application, MD5's object identifier is this ISO body, some numbers, terminology, and notation. In this document, a word is a 32-bit quantity and a byte is an 8-bit quantity. Okay, a sequence of bits can be a sequence of bits can be interpreted in a natural manner as a sequence of bytes. Okay, whereas each consecutive group of 8-bit is represented as a byte with the higher order most significant bits of each byte listed first. Okay, similarly, a sequence of bytes can be interpreted as a sequence of 32-bit word. A sequence of bytes can be represented as a sequence of 32-bit words where each consecutive group of 4 bytes is interpreted as a word with the lower order least significant byte given first. Okay, that is a bit different. Okay, a sequence of bits can be interpreted as in a natural manner as a sequence of bytes where each consecutive groups of 8 bits is interpreted as a byte with the higher order most significant bit of each byte listed first. Similarly, a sequence of bytes can be interpreted as a sequence of 32-bit words. A sequence of bytes can be interpreted as a sequence of 32-bit words. 4 bytes represent one word. My bad. where each consecutive group of 4 bytes is interpreted as a word. Where each consecutive group of 4 bytes is interpreted as a word. Yes, of course, that is what I said just now. Is interpreted as a word with the lower order, least significant bytes given first in a word. Okay. Let x1 denote x sub 1 if the subscript is an expression. We surround it in braces like this. Okay. Similarly, we use uh, upper thing for superscripts exponentiation, so that this denotes x to the ith power. Okay, let symbol plus denote addition of words, that is m- that is modulo 2 power 32 plus is addition of words. Let the symbol plus denote addition of words, that is modulo 2 power 32 addition. Okay, 2 power 32 addition of words, and x left less than s denotes the 32-bit value obtained by circularly shifting rotating x left by s bit positions. Okay, let not x denote the bitwise complement of x, and let x v y denote or bitwise or of x and y. Let x XOR y denote the bitwise XOR of x and y. Let xy denote bitwise AND of x and y. MD5 algorithm description. We begin by supposing that we have a B bit message as input and that we wish to find its message digest. Here, b is an arbitrary non-negative integer. B may be 0, it need not be a multiple of 8, and it may be arbitrarily large. We imagine the bit of the message written down as this: M0, M1, M till bit B minus 1, starting from 0. The following 5 steps are performed to compute the message digest of the algorithm. Okay, first adding padding, then add append length, then initialize buffer. Okay, let me do the append padding part first. Of course, that is the first part. That is how I will do it. The message is padded, extended so that its length in bits is congruent to 448 modulo 512. That is, the message is extended so that it is just 64 bits shy of being a multiple of 512 long. Padding is always performed even if the length of the message is already congruent to 448. Okay. Padding is performed as following. A single 1 bit is appended to the message, and then 0 bits are appended so that the length in bits of the padding message becomes congruent to 448 modulo 512. In all, at least 1 bit and at most 512 bits are appended. Okay, this int char pointer. I will be working with character strings. I will make a function called add padding, which will take in a char pointer s and return this. Right. First, I need to find out the length for s. Since I know that s is a string, therefore I can do int I, and for I equals 0, I plus plus I s I is not equal to null. Till then keep doing I plus plus. This will give me the length will be I minus minus. Will it be? If I have a two character word, then 0 would go to 1, and yes, I will. If this will give me the length of the thing. And now if I multiply the length by 8, I will get the number of bits in the sequence, and bits equals to I into 8. I have the number of bits now. What do I want now? I want to find out how much padding do I have to add to this to make it uh, to okay, integer padding bytes equal to if I find the remainder of bits with 512, I will get a number, and if I subtract that number from 512, I will get how much difference there is between this and 512. Right, right, yeah, right. Okay. So what is the number that I want to find out? Do I want to find out the remainder, or do I want to find out the value? I want to find out the remainder with 512. So uh, bits remainder 512. This will give me how many bits remain. Now, if this is if wait remainder if what the heck if what the heck if remainder less than 512 minus 64. What is 512 minus 64? 448 less than 448. Then I need to add then I need to add 51 wait shit padding bits equals 0. Then I need to add padding bits equals, if it is less than 448, then I need to get it up to 448. 448 minus rem minus remainder. Else, if it is equal to or greater than 448, then if it is equal to or greater than 448, then I will have to add to this 448 plus 512 minus 448, right? Padding bits equal to 448 plus 512 minus 448, no 51 plus 512 plus 512 minus remainder. Remainder is greater than 448. I know because of this. So yeah, I would get something equal to or less than 512, right? That would be my padding bits. And if I divide that by 8, that would be a very happy thing. Padding bits divided by 8, right? Now, if padding bits less than or equal to 1, if padding bits, how many bits? Well, I have made them padding bytes here. Int padding bytes equals to padding bits divided by 8. And now while like that, padding bytes less than 0, that is, I need to add only, not if, but while this is true, less than, nope, 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 greater than equal to 1. What will I do? First of all, I will add, I will have to add the 1, I will have to add, let me also get a different string, right, which will be the string that I return, character pointer padded input, which will have I plus 512 divided by 816, or maybe just in case 18 elements, right? And for I equals 0, si is not equal to null, I would like to do I plus plus, and inside that whoa, padded answer I equals si. This has to be padded answer I. What is wrong? Incompatible. Oh, yep, now it is correct. Now now when I have a padded string, okay, what do I do? Starting at index I, shit, first one has to be a 10, so I can add it manually, right? If padding bytes greater than equal to 1, then I can add the first one myself. Padded answer index plus plus equals padded answer index plus plus equals hexadecimal 1 0 is the first byte, and that's it. Yes, that is it. And padding bytes minus minus. While it is greater, I will keep doing padded answer index plus plus equals 0. All of them are equal to null character. That is crazy. Is that correct? That should give me the right thing, the thing that I want. Let's see. Return. Am I on the side of my screen? Nope, I'm in the middle. Wait, the screen is goddamn stuck. Shit, I do not know how long it has been stuck. Fucking hell. Let me re-add the screen again. Image slideshow, nope. Screen capture. Yep, and transform, fit to screen. I don't know why the heck that happens. Okay, yes, we did that. Added answer. Address of stack memory associated with local variables. Return. Oh, okay. I have to get something from malloc. It seems I cannot return stack, something from the stack. So. Char pointer padded answer equals int char pointer malloc. It takes in I plus 18 the number of bytes. Yep, it takes in the number of bytes. Now I can return it successfully. And here let me call char pointer. No, I have the secret up there. So let me call char pointer padded secret equals first I will have to add its prototype in here. Padded secret equals to add padding providing the secret. Now I want to print it, but I cannot print it normally. I can, okay, I will do that. I will do while true. I will just create a segmentation fault, put char, and also int I equals 0. I do not know how long this is going to be, but let me just go all the way and create a segmentation fault at the end. Clang part 1.c, put the output to dot slash out. Okay, it did not type out anything. It just created a segmentation fault. Oh, wait. I did not increase. Right. So I should have gotten something out. It should never have stopped. Shit. Why is it stopping? While I less than, let's say, 200. 200. Yeah, 200 is pretty large. Well, actually, how long am I expecting this to be? 1, 2, 3, 4, 5, 6, 7, 8. There are 8 characters. That is 64 bytes, 64 bits, 64 bits. So how long should be the padding? So here the value of I is 8, and I multiply by 8, that is 64, and 64 in div 64's remainder by 512 is 51 is 64. Now then I am checking remainder less than 448. It is less than 448. Then the padding bits becomes 448 minus remainder, which is 64. 448 minus 64 is minus 40, 44, 404, 404, 384. Yes, so I have 384 as padding bits. Then I get I plus 18. Hmm, 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 hmm. I is 8 and 8 plus 18, 26. Let's do 26. I should not get any segmentation faults now. I did get some segmentation fault, which seems just crazy. 8 plus 18 is 26. Let me do 20. Then, hey, what the heck? Why am I getting segmentation fault? Is it because I'm going too out of bound in this case? For si equals this and si is not equal to new line, keep going, and keep going, and then do the padded string thingy. Do here printf percentage new line padded answer. What's that out? Okay, so that much worked. This part worked. Where is the printf? Yes, this part worked. Padded answer. I got padded answer. Before returning padded answer, I would like to print it again. Line dot slash out. Okay, printing the padded answer is um giving me error. Replace this with byte, and what I want to add 3 1 2 3 4 is something like this, and I want to print the character for that byte. 8 bytes represent, yeah, so do I want to print the character? So today I'm not explaining anything, I'm just doing my thing. Padding bytes minus minus right. Oh no. Uh, oh yes. Oh yes. There. We got it. That was the error. Yep. Now we got it. Got it. Yep. Yep. Put star less than 20, 26 should be good. Yep. not char, but give me printf for giving the hexadecimal values. Percent x for this thing. Do I get 8? We should not have gotten 8 there. 8 bits represent 1 byte. 2 hexadecimal digits represent 1 byte. So I should not have gotten 8 here. I was expecting to get 128. Now 1 0 0 0 1 0 0 0. How is that represented? 1 0 0 0 means 8. Yeah, 8. Yeah, so 8 is correct. 8 is correct. 8 is correct. Yes, 8 is correct. So yeah, I'm getting padded thing, and yes, I should also return the length of that thing. Return this plus length, right? Nah, I'll just add null character at the end, but there are a lot of null characters, so that won't work. So I have to return the length for that string. Let me create a different structure for that. Type def struct for char pointer s comma integer length, and the name should be equal to hash. Okay, and in here I will do return hash. Okay, first I have to initialize hash answer equals padded answer comma index minus minus. Is that correct? Sure, that is correct. Return answer 29. Go back. This will return a hash. This will here do a hash. No, not this, but this hash unknown type. Okay, it's because it is defined now. Before this, hash padded secret dot s is this, and I less than padded secret dot length. What is length? Give me length. Will it have the length? Yes. And to get the length, I should not do minus minus here. Wait, that is much longer than what I expected. How many characters even are here? How many should I expect to see? Expect 16, 32. 32 characters. Are these 32 characters? ChatGPT. Many characters are in the above string. $39. I should expect to see 32, but I got 39 somehow. So that is wrong. That is wrong. That is wrong. I cannot even add padding. Okay, what am I trying to do here? First, I got the number of bits by getting the length and multiplying the length by 8. Right. Let him print all the numbers at the end. Printf bits is %d, bit is something, remainder is %d, and then padding bits is %d, and then index, nope, yeah, index is %d, and padding bytes is %d, and new line. Now remainder bits, comma, remainder, comma, padding bits, comma, index, comma, padding bytes, slash out, and I get that number of bits is 64. Yep. And I get 64 as remainder. What is the number of padding bits? 384, and index 86. 56. Why did I go up to index 56? That should not happen. Why did I go up to index 66? I got that padding bits was 384. Right, padding bits was 384. Then padding bits was 384. Okay, padding bytes was 384 divided by 8. 384 divided by 8, that is 48. Wait. It is 512 divided by 8. 64. 64 bytes is the length. Right? 64 bytes. 64 bytes is the length. And 64 minus 8, that is 56. And what was the index? Index was 56. Okay, so this is good. Index was 56. 64, and yeah, that is good. That is good. ChatGPT said that there were 39 characters, which is 39 in this, but in this, how many are there? How about this? How many characters are there? 72, which, what the heck? Let me also print printf length %d new line and padding secret dot length line slash out 56. Right, that is good. That is good. Now I can I have done the padding part. Yes, I have done the padding part. Now after padding, I have to add the length according to the RFC. Now step 2, add append length. Okay, a 64-bit representation of B. The length of the message before the padding bits were added, before the original length of the message before the padding bits were added, is appended to the result of the previous step. Is appended to the result of the previous step. Wait, I do not have to do this here. Should I actually, because I can just use secret from there. Right. Easy IT secret IT secret and yeah. I do not have to do this. Yep, I got this. Right. Now append length. A 64-bit representation of B bits is appended to the result of the previous step is appended to the result of the previous step in the unlikely event that B is greater than 64 modulo 64, then only the lower two bits of B are used. Then only the lower order, the MSB will not be used. These bits are appended as two 32-bit words, and appended lower bit first is accounted with the previous conventions. These bits are appended as two 32-bit words, as two 32-bit words, two 32-bit words. At this point, the resulting message after padding with bits At this point, the resulting message after padding with bits and with B has a length that is an exact multiple of 512. Eventually, this message has a length that is an exact multiple of 16. Eventually, equivalently, yes, multiple of 16 32-bit words. M0 till n-1 denotes the words of the resulting message, where n is the multiple of 16. Why 16 bits are used to represent 16 32-bit words. Yes, this is a combination of 16 32-bit words. So therefore, I can represent them as numbers. That also makes sense. Now I have to add the length. This function will return a hash called add length taken a hash called s, or a hash or a hash pointer. Doesn't really matter. Now I have a hash which has a string. Now I want to update that and add to at the end of the string the length of the original string. So first of all, I will get the length of the original string. It's I for I equals 0 secret I is not equal to null. Till then do I plus 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 plus. Right. Where b is the length. Okay, b is the length. Okay, so I have the length I. I have to represent I as two 32-bit words. I is already a 32-bit word, but I have to add it, convert the I. Fucking hell. I have to convert the I into character and divide I into 4 bytes and convert each byte into a character and add it to the string. Fucking hell. How do I do that? Yep, 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 yep. Yep, yep, yep. Okay, now how do I do that? I will have to do um, what I'm trying to do here is convert an integer to character. I have a 32-bit integer which I want to convert. I can make this not a integer but long, right? Yes, a long. And now I want to append something to that. Fucking hell. Yes, I can get individual bytes and put them up there. Yeah, by left shifting and find doing the and of the thing. Right, right. The message is padded, but I want to know how is the length added. The bits are appended as two 32-bit words and append lower order word first. I will append the lower order words first in accordance with the previous conventions. Okay, at this point, the resulting message after padding with the bits has a length that is an exact multiple of 512 bits. Okay, eventually this message has a length that is an exact multiple of 16 32 bits words. That is an exact multiple of 16 32-bit words. Let m0 to n minus 1 denote the words of the resulting message where n is a multiple of 16. Okay, so first I have to add the lower 32-bit word first and the higher 32-bit word later. So I have to divide this long integer into two 32-bit words and get the individual integer out of it. Ah, fucking hell. Have I got this? Yes. Okay, so int lower equals long. Can I do this? Bitwise and with ob or ox 16 bytes, right? I want to get the lower 32 bytes. So 0, 0, 1, 2, 3, 4, 5, 6, 7, 8. Now 1, 2, 3, 4, 5, 6, 7, 8. This should do it. Expected expression. Oh, I do this with I and int upper equals I and with 0x 1, 2, 3, 4, 5, 6, 7, 8, 1, 2. Oh, I just keep doing this till I reach that length. Why is this wrong? Integer literal is too long to be represented in any integer type. So yes, I can do this. To get the upper bits, I can do right shift this by 64. Why is this wrong? shift count width of type. Oh, oh, this sh does not shift by one. Shift, shit, how to shift individual bit in C. That is just that character, right? Oh, yeah, yeah, yeah. Wait. Okay, yes, 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 yes. That is correct. Right shift this by 32, and this, yes. I got the lower bits and the upper bits. Now I want char pointer lower chars, not this, lower chars, which will have which will be 4 character long, and upper chars, which will also be 4 character long. Well, I don't have to do this many in this. Right. Now I have two integers, two 32-bit integers, and I want to convert them into bytes. So, and j equals 0, j less than 4, j plus plus, and first I will get shit. I want to go this from 3 till j greater than equal to 0, starting from the last. First I want to get char character C equals to the lower 32 bits equals to lower and with 0x ff. Is that correct? Lower is 32 bits long. No, lower is 64-bit long. Then I messed up. I actually messed up. This has to be not like this. This has to be ff. Lower has to be equal to the 32 bits. 32 bits are 1, 2, 3, 4. 2, yep. 1, 2, 3, 4. Yeah, yeah. That sounds about right. And then I will do lower chars j equals c. This should work. This should work for int j again. 3 j greater than equal to 0, j plus plus, and then I'll put char. Now I will get the upper. Yeah, I also have to right shift it. That's correct. Upper chars j equals c, and after getting that, lower equals lower, right shift it by 8 bits. Yep, yep. And upper equals upper, right shift it by 8. Yes, I should at this point have everything that I wanted. Now I want to add it to the hash string. that I got in the first thingy. For that, I need to do malloc again and also do free. Right? When did I for what thing did I do malloc? I did malloc for padded answer, which is the string at the first part of that. Okay, okay. Now I will do char pointer ng length string equals char pointer malloc as dot length. It has 8 bytes less than what I need, plus 8, right? Now for int j equals 0, j less than s dot length j plus plus. I want to make this int index equals 0 and replace this with index, and here to index. Where is the nope index? And now I want to do length index equals length index equals s dot s slash index. No, not s. No, s dot s s dot s. That is crazy. Now I have that. I can free it. Free s dot s. Right, I can free that. I got the new string, and now I need to append the new character arrays to it. For int j equals 0, j less than 4, j plus plus. What do I need to do? Length string index plus plus equals. First I have to add the lower characters, right? No, this has to be j and this same but with upper characters. Then I can just return it if everything is correct. Hash answer equals length string comma index. All right. Now index should be equal to, at this point, 64. Hash length string equals. Let me add the prototype at the top. String takes it. String, change everything. Segmentation fault. Where is it? Segmentation fault. Where am I faulting? So I am faulting. The fault is happening somewhere in this function. Oh, oh, yes, yes, yes. Of course. Yes, this has to be minus minus, and this too has to be minus minus. That's plus out. Okay, length is 64. That is that a victory? I got 8 at this place. 8 0 0 0 and 0, which is 8. Then how many zeros? 1 2 3 8, and then 4 zeros. Fucking hell. So 8 and 4 zeros from hexadecimal into decimal, that would be 16 into 16 into 6. That is just fucking too big. No, that is correct. That is absolutely correct, because the lower 4 bytes were transferred to the upper portion. That is exactly correct. Shit, that is exactly correct. That is correct. That is fucking correct. Now, I've done this part, and till this part, my answer is fucking amazing. And now, step number 3. Just this much. Okay. No, and this is also a part of step number 3. A 4. Fucking hell. Hmm. Uh, Battery is fully charged. Laptop is hot. A 4-word buffer. ABCD. A 4-word buffer. One word is 32-bit long, and we are using 4 words. That is 128 bits is long, is used to compute the message digest. Okay. Here each ABCD is a 32-bit register, an integer for our case. These registers are initialized to the following values in hexadecimal lower order bytes first. Okay, these are initialized to these exact hexadecimal values. Okay, I will take that. Okay. Uh, Let me do that. Just do that. Int a equals 0x. What is the first register's value? Yes, 0 1 2 3 4 5 6 7. Right, and int b equals 0x 7 8 9 and 10, or a I guess. Okay. A 9 a b c d e f, right, and int c equals 0x f, and then just go back to 0. ef, wait, f, f, okay, f e d c b a 9 8, and int d equals 0x 7 6 7 7 6 5 4 4 3 2 1 and 0. Okay, I have initialized these values. Right, step 3 done. Step 4 is a bit long, and then step 5. Okay, step 4 seems to be the juice of it all. I got this. Step 4, process message in 16 word blocks. 16 word blocks. Okay, we first 16 words. 16 into 32 should be 512. 16 into 32 is 512. We first define our auxiliary function that we define four auxiliary functions that each take in input as input three 32-bit words and produce as output one 32-bit words. One 32-bit word. Okay, these are these functions. F, G, H, I. Okay, this is easy. This is easy. All of these functions are easy to implement. And each bit position, let me just first define them, or maybe first get them. Not X and then Z. X, Z. What is the order? What is the goddamn order for this? Precedence. Okay, I will take the OR operator as higher precedence, and XOR does not matter what is the precedence. And here that they have, yes, not of course has lower precedence than XOR, nor has higher, not has higher precedence than OR. Here I will take OR as higher precedence. XOR does not matter. XOR and then yeah, XOR and OR have the same precedence, therefore they had to give in the brackets. In each bit position, F acts as a conditional. Either X and Y or not X and Z. If X, then Y, else Z. Oh, yes, yes, yes. If X, then Y, else Z. And the function G acts as if Z, then X, else Y. The function F could have been defined using plus instead of this, since X and Y are and not will never have ones in the same bit positions. Yeah, yeah, yeah. It is interesting to note that if the bits of x, y, and z are independent and unbiased, the each bit of function x, y, z will be independent and unbiased. The function g, h, and I are similar to the function f in that they act as bitwise parallels. Okay, now let me implement these functions. I will implement them here. Comment them out. Okay, what will this return? This will return an integer function 1. What it will take? It will take in three integers: x, integer y, integer z, and return. I can instead create a micro for that, but this is also okay. What do I have to do? I have to do x and y, and then or. What is or? Or is this or of not x and z. That should be it. That is it. Now int func2 integer x comma integer y comma integer z. I don't want to use these brackets at the end of it. There is a return body. Ah, shit. Okay. Function 2 will do something like this. Return, what will it do? X and Z, and then or Y and not Z. And this is very crumpy. Let me make some space. Uh, yep, function 2, and now integer func 3 will take in integer x, integer y, and then integer z, return x and not y. Oh, wait. XOR. What is the operand for XOR? XOR and C. Bitwise operations. What is XOR? XOR. This is XOR. Yep, that is XOR. This XOR Y, XOR Z. And now in function 4 will take in the same inputs and it will return Y XOR with X, and X is OR with Z. Yes, now I have the definition for all these functions. Yes, done till this point. The functions g, h, and I are similar functions to f in that they act in bitwise parallel to produce their output from the bits of x, y, and z in such a manner that if the corresponding bits of x, y, and z are independent and unbiased, then each bit of these three functions will be independent and unbiased. Note the function h is the bitwise XOR or parity function of its inputs. Yes, this setup, this step uses 64 64 element table T1 to 64 constructed from the sine function. This step uses a 64 element table constructed from the sine function. Let Ti denote ith element of the table, which is equal to the integer part of this times absolute value of sine I. Okay, not okay. Let Ti denote the ith element of the table, which is equal to the integer part of this integer part, that is the lower 32 bits of this times absolute value of sine I. Okay, sine I is going to be than lower than 1. Therefore, I will get a fraction of this. This is equal to the integer maximum positive integer value, where I is in radius. Okay. The elements of the table are given in the appendix. Okay, let's see the elements of the table in the appendix. Should the appendix fuck it. Yep. Yeah. The elements of the table are given in the appendix to the following. Process each 64-bit word block for I equals 0 to n divided by 16 minus 1. where n is, where capital N, what is capital N? If I saw that, yes, capital N is the multiple of 16. Okay, capital N is a multiple of 16. How many words? Capital N represents how many half words are there in the number. Process each 16 word block. Okay, every 16 word block I will do this. Copy block in block I into X for J0 to 15 to this to M. What the fuck is M? There was M before, right? Where was M? M. They defined a table called M at some point. At the end of yep, here M. Yeah, okay. M is the table which contains equivalent. This message has a length that is an exact multiple of 16. 16 or 32-bit words. What the fuck do you mean by 16 or 32-bit words? Denotes the words of recruiting resulting message. Okay, so now they have changed word length from 32 to 16. Here they are saying 16 word. That is, a word is represented by 16 block, 16 bits. But at some point, I guess, in the notation and terminology, 32-bit, a word is a 32-bit quantity. Fucking hell. And 16 is not written there. I get this part. I have done step number 1. I have done step number 2. Now I have initialized these words. 32-bit registers, yes. Now we define 3 functions which will take in a 32-bit word in each bit position. F is something like this. Yes. And this step uses a 64-bit element table. It uses a 64 element table, okay, constructed from the sign function. So I have to construct a element table which will be like this. I can do that. 16 element table, an array of 16 values, 16 integers. Yes. Yeah. A global array of 16 values. Integer. What is the name of the table? Let's call it sign table. Sign table. It will have 64 elements. Yep. And let me do just a function which will return void and will fill sign table. It won't take anything. And for int I equals 0 till I less than 64 I plus plus sign table bracket I equals sign table bracket I equals this number, this mammoth. Control C, this multiply by abs sign of I. Using integer absolute function abs when argument is of floating type fix available. right, and then I would like to print the table. Copy, go to the top, declare it here just with the other functions, and yep, call it here till sign table. Yes, and for int I equals 0, I less than 64, I plus plus. I would like to print f percent d sign table bracket I, and also some space client dot slash out. Okay, everything is 0. Of course, because I'm converting it into integer. Fucking hell. Yes, yes. The output of sign will not be. Wait. Okay, instead of doing halves, I can do float sign equals sign of I. Alright, now sign equals sign less than 0. If it is less than 0, sign is less than 0, I want to do minus sign else sign. Yes, yes, yes. Right. Now this should work. Yes. Yep, yep. It works. It works. It works. It works. It works. Yep, I got the table. So I have done till this part. Now do the following. For each best appeal this, do the following. What do they mean by 16 word blocks? 32-bit register, and these will be these words. Okay, but what do they mean by 16 word block? We first define our auxiliary function that each take an input 3 32-bit words and produce an output as a 32-bit word. Okay, in each bit of position. Okay, that I understand. Right? Yes, that much is okay. This step uses a 64 element table, which I have implemented as an array constructed from the table sign function. From the sign function, let ti denote this, where I is in radius. The elements of the table are given in the appendix. Do the following. Process each 16-bit word block. Okay, I will take 16 bits. Oh my, that is 16 bits, 2 characters at a time. I got this. I will take 2 characters at a time for length divided by 2 and copy block I into x. Wait, okay, I will copy block I into x, and wait, x is a 32-bit word, and how am I going to copy a 16-bit word into a 32-bit? A multiple of 16 32-bit words. Multiple of 16 words. Multiple of 16 words. Am I stupid or am I just unable to understand this? a 16-bit representation of B. Okay, that much I have done. At this point, the resulting message after padding with the bits with B has a length that is an exact multiple of 512 bits. Yes, that is an exact multiple of 512 bits. Equivalently, this message has a length that is an exact multiple of 16 32-bit words. Let m n minus 1 denote the words of resulting message where n is a multiple of 6. Okay, I'm just supposing that by 16 word by 16 word they mean a 32-bit word. That is what I'm going with, because that 32-bit is what they have used as word length here and for these functions also. So 32-bit for j equals 0 till fuck. Then why are they doing from 0 to 615 here? Fucking hell. Okay. There are going to be a couple of rounds. For every word, for every 16 word block, n divided by 16 minus 1. There are, what is 16 into 16? 16 into 16. There are n 16. Wait, what is 32 into 16? 512. Okay, if n means a 32-bit word, then if n means a 32-bit word, if n means a 32-bit word, if n means a 32-bit, how many 32-bit words are there in the padded string? Then n divided by 16 means how many 512-bit words there are in the string. And I will go for every, don't say 16 word block, 16 word block. Okay, maybe I'm getting to know this. Okay, here they said 16 words. Yes, fucking hell. Yes, they are not stupid. Of course, of course, of course, of course, he is not stupid. Yes, by 32-bit, they are not referring to 16. They are referring to words. A word is 32 bits long, and there are 16 such 32-bit long words in every 512-bit. Okay, okay. Yes, 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 yes. And gracias. Now, and what does n mean? N mean how many 16-bit values there are. Wait, does it mean that? And let m to n minus 1, where n is a multiple of 16. O denotes the words of the resulting message. N is a multiple of 16. Yes, n is a multiple of 16. Yes. And n is the number of words that there are. One word is 32-bit long. Okay, okay. N represents the multiple of 512 for our string. Yeah. Our string is a multiple of 512. If we multiply n by 512, we will get the length of our extended string. Right, right, right. And n is the count of how many 16-word blocks there are. Right, that also makes sense. For j equals 0 to j to 15, yes, for every single word in that 16-word block, what will I do? I'll do set xj, set one word xj to this end of loop on j. Save a as aa, b as be, and c as cc, and d as dd. And what the heck are a, b, c, d? A, B, C, D are these. Okay, A as AA, B as BB, C as CC, D as DD, and now round one. Okay, let me just go through it once. Round one, for round one, we will do let A, B, C, D, K, S, and I denote the operation. A equals B plus this whole thing to the following 16 operations. Let this 1, 2, 3, 4 denote the operation. This, let this denote the operation this. If I have A, B, C, D, K, S, and I, then this this means this A equals B plus uh, this F of these B, C, D, and that of that. Okay, and save A as this, and by set X to this, I guess they mean set M this equal to this. I'll do this. Update the values of ABCD, and this is the order. This, and and till this. Round two, let this denote the operation this. Fucking hell. And then I will do this much, and this represent this, and then I will do this much, and this represents this equation, and then I will do this much. Okay, then perform the following additions, that is increment each of the four registers by the value it had before this block was started. Okay, I took the and of them, right? Hmm. Okay, this represents the original value. Okay, I got new. Oh, is this the answer? This is a 32-bit. These are just four 32-bit numbers. This does not mean the answer. The message digest produced as output is ABCD. That is, we begin with the lower bytes of 32 and end with the higher order bytes of D. This completes the description of MD5. A reference implementation in C is given in its appendix. L- But A, B, C, D, they are, what are they? They are integers, that is 32-bit values. So 32, 32 into 4 does not mean, oh yes, the output is 128-bit. So yeah, that is cool. That is cool. Yeah, and we will be doing the remaining tomorrow. But for now, we know that this much, and we only have to write a function and then put it into a couple of loops. We have until this, and there is only a small portion remaining. And let me do a little thing. Eh, That is do a quiz, and then I will end the stream. South America, nope. Capitals of the world. Hardest level, level 3. Let's do it. Managua. Wait. Do I know Managua? Yes, of course, Managua, capital of Nicaragua. Banjul is this Gambia. Nicosia, wait. Cyprus, right. Seoul, South Korea. St. George's. Shit, yes. I know. Is it? No, this is Georgetown. This is Suriname. This is Georgetown. St. George is Grenada, and I do not know which one of these is Grenada. Yes, that was Grenada. Addis Ababa. I have no idea what is Addis Ababa. Estonia. Okay. Yaoundé, which is Cameroon. Brazzaville, which is this Republic of Congo. Mogadishu. I think I know. It is maybe Somali. Yep. Belgrade, Serbia. Thimphu, Bhutan. Yes. Chisinau, Moldova. Brasilia, Brazil. Vientiane, Laos. Rome, Italy. Amman, Jordan. Valletta, 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 Malta. Yep. Lusaka. Nope. No idea. Nope. Not even a clue. Nope. No idea. Oh, okay. It was this Zambia. Tehran, of course. Iran. Damascus, of course. Syria. Syria. Basseterre, Saint Kitts. One of these. Suva. Do I know Suva? No, I know. I don't. Let's do this. Suva is that Samoa? Maybe Santiago, Chile. Port Louis, which I don't know. It could be one of these, or it could be in the Caribbean. It is this Mauritius, Kampala. No idea, right? Nope, no idea. It is this Uganda, Khartoum, Sudan, Berlin, Germany, Bangkok, Thailand, Djibouti, this Jerusalem, Jerusalem, Israel. Oh, yeah. This was good. We were able to come this far in by reading the RFC and implement it. And how much time did it take us? I think I have to increase the duration of streams, or maybe I have to figure out some way that I want to stream for like 5 to 6 hours, so that coding for longer hours is better than coding for shorter hours. But I cannot just go off for a break, but I can come back after 30 minutes and start streaming again and start end this stream. Okay, I will figure